We're here to see why a cyclic quadrilateral, also called an inscribed quadrilateral, that is a quadrilateral that sits inside a circle and where each vertex of the quadrilateral sits on the edge of the circle. Opposite edges in the quadrilateral are supplementary, that is, they must add up to 180 degrees. I made a previous video proving this, which I've linked in the description and the comment section, but we're here to see an even simpler version of that proof. So let's get started. We'll begin by just highlighting one of the angles, and I'm going to draw one of the diagonals of the quadrilateral, and that results in two triangles where the highlighted angle is the top angle in the bottom triangle. We know that the sum of angles in a triangle is 180 degrees, so the sum of the highlighted angle plus the two base angles in a triangle must be 180 degrees. Let's give the base angles two different colors to distinguish them, and we'll drop an equation to show that the orange, blue and lilac angle add up to 180 degrees. Next I'm going to add the second diagonal of the quadrilateral, and this will help us get a few angle values in the upper triangle. And to do this, we're going to make use of one of the other circle theorems, the one that says that angles in the same segment are equal. I've made another video explaining why this must be true, and I've linked to that in the comment section and description. Now if we focus in on the orange angle, you should be able to see that the angle is within the larger segment. So the angle is not in the bottom segment, it's in the top segment. But there's another angle in that segment, and hopefully you can see that one. I'll highlight that angle, and hopefully you can now see that both of these angles are in the same segment, that is the upper segment, and they both have to be the same angle because they're separated by this distance, which means this angle is the same as the orange angle. We can now repeat the same process for the blue angle. Now hopefully you can see that the blue angle is in the left segment and that there's another angle in that segment. I'll highlight it so you can identify it, and you should see that this angle must be the same as the blue angle because the width of both angles are created by this same line. So let's highlight this other angle which is equivalent to blue. And now that that's done, we can show why opposite angles must add up to 180 degrees. If for the moment we focus on the angle at the bottom right, the lilac angle, the angle opposite to that is the top left angle, and let's highlight that. What's the sum of these two angles? Well, their sum must be blue plus orange plus lilac, but we established earlier on that the sum of the blue, orange and lilac angles is 180 degrees, so the sum of these two angles which are opposite each other is 180 degrees. But since the entire shape is a quadrilateral, the sum of its degrees is 360, and if the sum of these two opposite angles is 180 degrees, the sum of the other two opposite angles must also be 180 degrees, because 180 plus 180 is equal to 360. And that's how we know opposite angles in a cyclic quadrilateral must add up to 180 degrees. In other words, they are supplementary. And that's our proof. Well, that's it for now. Thanks for watching.